Hello and welcome to episode 5 in the Delphi Training Series brought to you by 3dbuzz.com. My name's Buzz.
And I'm Logan.
And before we get started, I'd like to take a moment and point out that the high-res version of this video will be made available in the next couple of days. You'll be able to find a link to this version on the YouTube site located right next to this video. That is on the right-hand side, ladies and gentlemen. Now, if you happen to be viewing the high-res version already, then don't worry about it. But if you are looking at this on YouTube right now, please keep in mind we have no control whatsoever over the resolution. We know the quality is poor. We can't help that. We have to encode our videos at this resolution for YouTube in order to upload it. That is why we make the high-res versions available. So check back in a couple of days. In the meantime, watch the video and hopefully pick up a thing or two. Now, in this episode, we're going to be taking an introductory look at subroutines. The focus? Procedures and functions. That's the goal. Procedures and functions are really very, very important concepts to understand because after this video, we're going to be using them all the time. Now, this is an introductory look at procedures and functions, so the idea is that by the time we get to the end, you guys have a basic understanding of how to set them up, how to use them, and that should do the trick. But later on, there's some things we can do that take the subject just a little bit further. Keep that in mind. Now, starting with Delphi Training Series, VTM number 1, I said that we were going to try to create an application with every single episode that's released. Well, that worked out pretty good for episode 1, episode 2, and even episode 3 where we wrote a full game. But once we got over to episode 4, things got out of hand, and they got out of hand quickly. We decided to go ahead and write a full-fledged application that had some practical use, and that is the Mp3 Player. So Logan, if you want to go ahead and open that up real quick, just in case any of our viewers happen to have missed out on watching episode 4, where we went over what this application was capable of doing, this is the program that we're now working on creating. Well, in order to create this application, we needed a lot of concepts covered. We needed to go over variables, which we did in episode 4. We needed to go over procedures and functions, which we are doing in this episode. We're going to need to go over looping and a few other things, but we needed to break these up into several different videos because it was going to end up being too big and we would not be able to upload it to YouTube. I mean, it's going to end up being, 6, 7, 8, maybe even more hours by the time we get to the very end of this. The variables video ended up being almost an hour and a half long, and there's no telling how long this video will be, though I'll do my best not to talk quite as much. So anyways, this is the application that we are working towards, so I don't want anyone to think that we are skipping out and not writing an application. We've just got to cover these concepts first. In episode number 6, the next VTM that's going to be released, we will start writing the Mp3 player. So Logan, go ahead and minimize that. Now, subroutines. 4 important objectives in this VTM, and here they are. First of all, we need you guys to understand what they are. What is a procedure? What is a function? Next, why do we need them? Why are they so important? Next, what types are there? And there is 2 different types, procedures, functions. And what's the difference between them? And number 4, how do we use them in our applications? And that really breaks down into some sub-objectives, if you will. How do we declare them? How do we call them? How do we send data to them? And how do we receive data back from them? So that's our objectives. And by the time we get to the end of this video, we're going to take a few minutes and see if we can slide a couple other things in on you guys that are really neat. As we write some of our own procedures and functions near the end, we're going to have an opportunity to introduce you guys to a few string functions. It's kind of cool. We're going to get to show position, delete, and copy. So good stuff to come. All right, let's go ahead and start with our objectives. Number 1, what are procedures and functions? Well, simply put, they are it's a piece of code. It's a chunk of code, if you will, that has been packaged, and that packaged has a simple name, an alias, if you will, that we can call upon in order to execute the code that is packaged inside. And generally, you're going to create these packages where they're targeted at the completion of some sort of task. That's the idea. Now, let me see if I can give you some sort of example, an analogy, if you will. I know, let's pick on email. Everybody's got email, right, Logan?
Yeah, just about anyone who operates in any kind of communication will use email at some point.
That's right. I mean, doesn't matter. Nowadays, if you have a calculator, it can send email. And with email, we all know we have an email client. And the email client needs to talk to the email server in order to send and receive email, and you guys get the picture. Now, let's focus on the send receive, or let's just call it the check email. Okay? That's a task within your mail client. You know, there's a lot of different things you can do. I mean, you can set up rules, you can send email, you can check email, you can open email. All of these are tasks, if you will. So let's focus on check email. To us, it is a matter of simply clicking a button to check the email. We lose control of our client for just a second. And what the client does is it establishes a connection with our server. It then makes a request to the server for any email. If there is any email, the email is then sent back to our client, and then the client is going to populate a list and then give control back to us, and we're like, hey, we got some email. We're pretty popular. All right, very nice. So that is, of course, this is a gross simplification, if you will, of the entire process, but again, it's just a simple analogy. That's what I'm looking for here. So the key thing is a task has been established, and it's a simple task as far as we're concerned. We just simply say, check email. As far as the client's concerned, it now knows it needs to handle this series of things in order to get that result back to us. So that's a very simple look at what a procedure or function might appear like, right, Logan?
Right, it's grouping a series of steps into a single task.
Ooh, a series of steps within a single task. Very nice. Okay, I like that. So with that, the next question is, well, why do we need something like that? Well, you would think that's kind of obvious in a sense because, it's simple. I mean, we just say check email and all these different things happen. So it's kind of obvious. Well, there's actually 4 different areas that we can break this down into why we need procedures and functions. First of all is to reduce redundancy in our program. And Logan, earlier when we were talking about this, you had a great example when I mentioned the whole email client thing, and that is when checking email with our client, there's 2 different ways we can go about doing it. One, manually. We push a button that says check email. As a matter of fact, you know what? Let me go ahead and jump over here and pull this guy up, which has got some stuff on it that I was playing with earlier. It's Logan and I was just talking about how we were going to do this lesson. All right, so we want to check email, right? So check email. And that is check email, I promise. And this is a little cloud-like thing. This is where all the code resides to check the email. Now, we can manually push a button. So this is, I'm just going to say man. That's our manual approach. We push the button, and it is going to call upon this task to check our email. But then there's another method a client may go about checking our email, right, Logan?
Right, you could have some type of automatic or automated checking where you'd have something that's more or less a timer that goes along and checks email every so often.
So kind of like a little timer like that, right? So it's going to automatically check email every so often. So here is an example of the first main reason we'd want to use procedures and functions, and that is to reduce code redundancy. In this particular case, we only had to write the code for check email, this stuff right here, one time. Then, when a user came in and pressed the manual button for checking the email, this code is executed. Well, when the timer hits every 15 minutes or whatever it may be, once again, the same exact code executes in order to check the email. This is really convenient because if we decide to later on, let's say, check email, let's make it a little bit more sophisticated. Let's have it do some more stuff for us. Well, we come into one area, one little package, if you will. We add some additional lines of code. We maybe changed a few things around. But look at this. Our manual button and our timer still uses the same task for checking the email, so they both, in a sense, check email properly, the new and advanced way, right?
So if we ever work on the steps required to check email, we don't have to worry about any buttons or timers or anything else that ties into it. We have one place where we update the check email functionality, and then that's spread out and accessed through all the other...
Yeah, exactly. I know where you're going, even though you're trailing off there. I mean, it's so much better than if you think about it, you know, if that's another cloud. If the manual had its code, and the timer had its code, right? Then if you made some changes in here, and you forgot to make changes over here, now we have a problem. Agreed?
Right, if you had like individual steps inside of each of those.
Right.
And they had those duplicated over on the timer.
Exactly.
And you update the buttons version. Now the timer and the button they do different things.
But it's redundant code, isn't it? I mean, it's supposed to be the same code. If
they're both checking email, then it's going to be the same code in both cases, so it'll be redundant.
Exactly. So the idea would be to write a simple procedure, something like check email, that would handle doing what we need it to do, the specific task at hand, and then we can call on it from multiple areas. So why do we need procedures and functions? That's number one, to reduce redundancy in our code. Number two, to modularize our code. That way we can reuse modules quite easily in other programs. Let's say, for instance, we were writing a 3D game engine, right? And we had some elements inside the engine, some rendering elements, that did some common tasks that would be used no matter what kind of 3D game engine. Let's say it was like a DirectX initialization routine that handled cleaning out buffers and setting stuff up, etc., etc. And we write the first game, and it's very successful. Now we start writing another game, and it's going to use DirectX again. And, well, we're probably still going to need to do the same sort of initialization routine, right?
Right, and then it gets kind of complicated, as in there's lots of things you have to do.
Right.
It's like setting the resolution and any other parameters you have, and you might have a few hundred lines of code by the time you have everything initialized.
Precisely, and it would be real nice to just grab a routine, a subroutine that we've already put together and reuse it in this new application. It definitely saves on time, and that's a really big thing. So keeping it modularized, very cool. And by keeping it modularized, it does something else for us, and that is it can take what would appear to be a very complex application if your code was not modularized, and by breaking it up, in a sense, it simplifies your application. Because if all your code was just strung together and went on and on and on, and you had no specific way that it was broke up, that can become kind of complicated when you're troubleshooting something, trying to find something within the code, etc., etc. If you had it broke up into modules, if something goes wrong with your application, you know exactly where to go. For instance, let's say something's wrong with our check email. Every time our client uses this application, or client, I'm now selling our program to somebody. Every time the user sits down behind the mail client and clicks the check email button, he gets an error. Well, we, as the programmer, now take a look at the source code. We don't have to dig through thousands of lines of code. We come straight in here to the check email routine, and we start digging through that to find out what's generating the error. It helps to simplify what would, in essence, be viewed as a complex application by breaking this up into modules. Agreed?
Right. It takes all of the steps into check email and collapses them down into one step. And
exactly.
Then things like the manual button and the automatic timer each look like they have one step.
Right.
The one step is the same step, and therefore you leave all the code in just one place.
So again, very, very complex applications can be simplified. I mean, you still got to have the complexity of the code there, but in essence, it is simplified because all the code is now organized, if you will, in such a way that it's very easy to jump right to specific areas. And finally, by doing this, having these functions and procedures and modularizing our code, we improve program readability, which means if Logan was to go in here and write the check email routine, and then I came in later on and I needed to make changes to his code, I can quickly find the check email routine and make whatever changes I need. Because it's easy to follow, it's easy to read. If all the code was just slapped together and it's just line after line after line and it wasn't broke up into different modules or different procedures and functions, it could prove to be quite challenging to find exactly where I need to go in the code to make changes.
Not only that, you would think you found the right place. Like you find the button,
right,
and you fix the check email code, and then every 5 minutes when the timer hits, it breaks. And
right.
You wonder why, because you fixed the check email code.
Exactly.
And if you just fix the one under the button, that's only one copy of that code. If it's modularized and you fix check email, then everything that uses it. If you fix what looks like you fixed the button, well, you fix the timer too, and anything else.
Exactly. So very, very important concepts. I hope you guys see exactly why we can use these. Now, what types are available? You know, you're dealing with subroutines. What types do we have? We've got two. We've got procedures. I'm just going to write P-R-O-C because it's too much to write. And we've got functions, F-U-N-C, functions. Okay, you guys just stipulate. I wrote out the entire thing. Now, again, here is some code. I'm just drawing my little clouds around it to represent packaged code. So the idea is a small amount of code that's been packaged with a simple name. So we'll call this myproc. Okay. Then here's a function. Again, same type thing. Give a small cloud-like look. Inside of it, we have code. And this is, we'll give it a name, a very simple name to call upon, myfunc. Here's the difference. A procedure is something you simply call upon to execute, do a specific task at hand, and that's it. When it's done, you just continue on like normal. And an example would be the check email button. Hit check email, it goes and does all of its stuff, and then when the application's done checking the email, you get control back of your program and can do whatever you want. Simple enough. A function, on the other hand, is just like a procedure in that it will execute a series of lines of code, but when it's done, it will return data back. So that's the key thing. It actually returns data. So a really good example, let's say, again, we were writing perhaps a game. Okay, let's go back to the world of a 3D game. We could have a procedure called game init, where we say we're going to call the game initialization procedure, and we're not looking for it to give us anything back. But what we are looking for is it to initialize our display drivers, initialize our sound drivers, set up all of our objects, get everything ready to rock and roll. Okay? Now, we may have written several mathematical functions that we can pass data to the function, and then the function is going to do some work on that data and give us a result back. So now we have some information back that we can use. Does that make sense?
Right. I was thinking of a real-world example of a procedure and a function.
Okay.
You could say you'd have two, we'll just call them containers or ideas.
Okay.
One is to throw away or to dispose of garbage, throw something in a trash can.
Okay.
So we'll call that one throw away.
Okay.
Another one is call your friend or call a friend. So you use the phone to call your friend.
Okay.
In the throw away procedure, you just do it. You throw the trash away and you don't expect anything.
Oh.
You don't want to get anything back. You don't want the trash back out of the garbage. You just throw it away. It gets thrown away. Maybe it gets taken to the dump or any other things.
But you're done with it. You throw it away.
You say throw away, you're done.
Okay.
When you go to call friend, you're expecting your friend to say something in return.
So you're expecting some sort of communication coming back.
Right. You've told him what color the sky is, and you're waiting to hear what his thoughts are on that.
Very, very nice. Okay, so that is a very basic idea of what a procedure is and what a function is. They look almost identical. The key thing is a function will give you a result back. A procedure will not. All right, so with that, Logan, let's go ahead and jump over to Delphi, because the next objective we need to conquer is how do we use them, and I'd like to start out with the anatomy of a subroutine. So let's go ahead and jump over into Delphi real quick. And let's see, for starters, I know how we can show one real quick. Just give me a quick VCL Forms application.
Okay,
Yeah.
so they've got VCL Forms app.
And a giant button. Yeah.
Giant button. Okay.
Giant button.
That's
a giant button. That's what I'm talking about. Now, double click on it so that we can start coding. All right, good enough. Let me steal the mouse from you. All right, check this out. You guys have actually been working with procedures since VTM number 1, since we got you guys to get in there and get your hands dirty and start doing some coding. Check this out. We have a procedure set up. With our application right now, it is set up in such a way that when it runs, there's a giant button, and the button is waiting to perform a task when the user clicks on it. As a matter of fact, Logan, if you don't mind, go ahead and put some code in there. Just have a simple show message or something that says, hello world.
So kind of redoing one of the first apps. Yeah,
that'll work. Yeah, something like this. Okay, very nice. So now, of course, if we were to come in here and run our little application, giant button, we hit the button, and it does something. We called on a procedure, and that procedure executed its code. Look at this. We're kind of hung up right now, aren't we? We're waiting. We've got to finish this. Now we're back from the procedure. We can call on the procedure again. We're kind of hung up right now. We need to finish. And now we're back from the procedure. Make sense?
Right. Another way to look at that is that's how existing functionality gets translated into custom functionality. The programmers of Delphi set up a button, and the button could what could it do? It could be clicked.
Right.
But we needed to extend upon that. So they've got that, and you even saw it getting created. We didn't create the button click procedure. It got created when we went into it and designed it.
Exactly.
But after that, all a button knows how to do is click. What we did is said, okay, this is what click really means. It means a series of steps. In our case, one step, and that was the show message.
Very cool. So let's go ahead and close this out. Jump back over to our code, and now let us take a look at the anatomy of a procedure. Well, first of all, as I said, a procedure is more or less a chunk of code that is going to get packaged and executed when it is called upon. So first thing we've got is, let's just call it our shell. We're going to keep from getting too technical with declarations, forward declarations, and things like that. So here's our shell. We start out by defining the procedure, if you will. We start out with the word procedure. Then here is the name of the procedure. Here is any parameters that we can send to the procedure. And then we have a begin and an end. And this is what is going to basically package or wrap up our code that will get executed when the procedure is called upon. Okay? So, a real quick look at the anatomy. We have the shell packaging, if you will. We have any parameters. We have the body of code that will be executed when it's called upon. And this is a procedure, so you can't see the return type. But if it's a function, the final part of the anatomy is the result, or what is sent back out of the function. And we'll look at that in just a second. I just wanted to show you guys that you have actually been working with procedures all the way up to this point. You haven't been writing your own. We're about to do that in just a second. But you have indeed been working with the code inside them. So that's very, very nice. As a matter of fact, if you guys open back up Flea right at this moment, pause the video, open it up, take a look, you're going to find that everything's very nicely modularized. The timers each have their own on-timer event. They're just procedures. They get called upon to execute every time the timer interval is up. The mouse, it has its own abilities, basically based on as the mouse is moved around the form itself, and it calls upon that procedure. Procedures left and right. We just haven't got into writing our own yet, but we're about to. Now, one thing I'd like to point out here is we are using this procedure. This procedure actually belongs to the form. And now we're getting into an interesting world. We're starting to cross over into object-oriented discussion at this point. So I want to take this very light because I don't want to focus on it heavily at the moment. But this procedure belongs to the form. It's more precisely, it's part of the button right here. When the button's clicked on, that button's associated with that procedure. So you'll notice we also have a declaration of the procedure up here when we are defining our form. Okay, so the program, it's not the program itself, but the window, the form itself. So when defining the class, the form itself, you'll notice that right here we've got the button defined and we've got the procedure defined as well. And my mouse is giving me a hard time at the moment, just letting you guys know. So anyway, so here's the procedure defined. So anytime that you're going to start creating these procedures that are tied to controls that are on your forms now, you're going to find declarations for them up in the classification area or the class itself. Right.
There's a lot of times where you'll see something defined before it's actually implemented.
That's right.
You see what its name is, you see any parameters it takes in, but that's it. You don't write any begin and end, you don't write any code at that moment.
That's right.
You just basically made the system aware of that. This is going to exist.
That's right.
I haven't said what it contains, but I have said that it is going to exist.
We are declaring it.
Exactly.
But that does not get us away. By having that there, does not get us away from having to redo it again here with the begin and end. That is a must. All right, so now that we've taken a look at this, Logan, let's go ahead and close this out. Don't worry about saving anything, even though it was a nice big button. Let's go ahead and do a new console app. Let's keep this real simple. All right.
So here's our console app.
So console app. Now, we're not going to have to declare our procedures or functions in advance in this particular case because these procedures that we're writing at the moment don't belong to the object, the form itself and the button and all that good stuff. That stuff we're going to focus on as we start getting into object-oriented programming. So right now, these are just going to be freestanding procedures that we can call on as we need to. But the interesting thing is the creation order of these procedures is going to become very important depending on how we plan to call on them. And we'll cover that when we get near the end of this particular training video. So let's start out, Logan, by writing a very, very simple procedure. Let's, I don't know, what would be check mail. We talked about check mail. Let's write a procedure that's called check mail.
Okay. Now what I'm going to do is jump up above our begin and end, because this is a simple console program.
Mm-hmm.
And so we have this defined as a program, we have what we use, and we have a main, begin, and end, and this is the begin and end for the entire program.
Right.
What we need to do is go outside of this. So before we get to our initial begin, and right here we can start defining a procedure.
So here we go. Using the anatomy that we discussed a second ago, we first begin with the word procedure. Okay. Next thing we do is we give the procedure its name. Let's call this check mail. Now, we're going to put an open and a closing parentheses, though this is not required since we're not taking in parameters. So you can put them there or you don't have to put them there. But, Logan, I'm going to require you to use these just for a couple of times. And then as we start getting into more sophisticated applications, like the Mp3 Player, we'll just drop them all together if the procedure doesn't take any parameters. We'll discuss these parameters in depth in just a second. Okay, so now we've got that. We need a terminator. And then next line, a begin and end. And then Logan puts the begin and hit enter. It automatically puts the end in. So there we go. We have just created the skeleton of the check mail procedure.
Or the shell that you were talking about before.
Or the shell, absolutely. So if you don't mind, give me 4 right lines. And let's just say, like the first right line is going to say establish connection, retrieve mail, then close connection, then display new mail. So guys, this is a great time to get a sip of your coffee. Yeah. And just copy and paste.
So we'll
retrieve mail. So we establish our connection. Now we want to retrieve the mail.
Retrieve mail.
Okay. And then the next thing we want to do is close our connection. And then the next thing we want to do is display the new mail. Kind of cool. We're actually mocking, in a sense, what we just described.
So aside from being able to use a network connection and being able to communicate with it and being able to close it and being able to display emails, we'll replace those with text for the time being.
That's right. Simplification, ladies and gentlemen.
Welcome to Pretend Email 1.0.
Now, if you compile this right now, what's it going to do?
It is going to compile just fine.
And it'll run just fine, right? Ready? Watch. There it went. It ran. We didn't tell it to actually do anything in the program, but here's what I would like to take a moment and show you guys what's happened inside. So let's go ahead and clean all this out. Let us come over here to the side, and I'm going to draw out some memory. Yes, that's memory. That's been kind of like torn off, right? That means the memory range continues to go like such here.
I see. It's not because it's melted after being left outside.
Okay, fine. Be a smart aleck. Okay, so you've just created a procedure, and what happens when we've compiled and executed this program is our procedure gets put over here into memory, and it was called check mail. So our lines of code, if you will, are sitting right here inside this procedure. Now, we run our program, it gets put over here into memory, but nothing happens. Nothing whatsoever. We need to see something happen, and in order to see something happen, here's the big one. We need to call our procedure. You guys want to talk to a friend via the telephone? What do? You call your friend. You do your little bit of communication, and when you're done, you hang the phone up, and you return back with life.
Right. Just because the phone is sitting there doesn't mean that you're going to call your friend because the phone's there.
Right.
If you don't pick up the phone, then you're not going to be calling your friend, even though the phone's sitting there.
Exactly. Now, our friend, checkmail, is just sitting there in memory, dying to be called upon so that it can do some work. Well, to call on it, it's really simple. We don't have to do anything fancy other than call its name. Logan, go ahead and show them what I'm talking about.
All right, so
remember the begin and end that Logan was talking about down there at the bottom with the big comment saying add your code here? Well, Logan's going to kill that out, and watch this. He is going to call checkmail.
And you want to keep it the standard where we put the...
take those out in the actual calls. Would you believe it's that simple? Now, at the moment, it's still going to just flash super fast because we've got nothing to hold us up from the console going away. Yeah, go ahead and show it. Ting, ting. There it went. Real fast. So let's go ahead and go ahead and add our read line in there, just so that we can pause things till Logan hits enter. Now when he runs it, look at this.
So 4 steps have occurred, even though we've only looks like we've run 1 step.
Yep, and let's prove it to him. Watch how easy this is. We can call it over and over again. Let's go ahead, hit enter, and do another check mail. Now let's run it again. Check that out. Establish connection, retrieve the mail, close the connection, display the mail. Oops, establish connection, retrieve the mail, close the connection, display the mail. That's a lot of code now that we were able to reproduce with only 2 lines of code there. So we've got 8 lines that we've done, but we only had to write 2 lines of code. Pretty straightforward. So now what happened, go ahead and jump out of that. Let's jump back to our whiteboard, is basically when we called our procedure is, I'm going to, once again, greatly simplify this. Our procedure is pulled off the shelf. Okay, so this is going to be considered the shelf in memory. And we've had check mail just sitting there on the shelf. We have pulled it off the shelf. So here resides check mail, and we've done the lines of code within it. And once we have done with it, we have discarded it and continued with our application. Now, let's take a second and make this just a tad bit more sophisticated. Logan, go ahead and bring Turbo Delphi back up. Now, let's go right before the begin, the first check mail, and let's do a write line right here saying something like, write line just came into work. Okay. All right, and now we need to check our email. So the next one will be check email. Then after that check email, let's tell it to go to lunch.
So replace this one?
No, we're actually going to insert between those 2.
Okay.
Yeah, so now we're going to go to lunch. And then we're going to check email again. So this really works out very, very well. I'm going to steal control from you for just a second, Logan. So the way this works is basically we do this line first because that's where we begin our program. So we write the line out, just came into work. Okay, now we're going to check our mail. All right, here's the key thing. We remember where we're at in our program because we've got to come back to here when we're done. So we pull this procedure off the shelf and we execute the code inside of it. So we execute this line, we execute this line, we execute this line, we execute this line. What's left? The end. We're done. So since we're done, we now return back to where we were just at and continue with execution. So we then do this next line. So we're going to write out go to lunch. Then we come down to the next line. And this mouse is just not wanting to work with me. All right, so now we're going to check mail again, meaning, once again, we remember where we are at. We come up here. We execute all of those lines. We get to the end of the procedure. We then put it back on the shelf. We discard it. We're done. So we come back down here and we pause for the user to hit enter, and we're done with our program. So that is what's happening. So let's first demonstrate that, Logan, by running our little program. Let's make sure it works. Aha. So the first one, as you can see, is we just came into work, and then we established our connection, retrieved our mail, closed our connection, displayed the new mail. Then it was time to go to lunch. After lunch, we came back and we established a connection, we retrieved our mail, we closed our connection, and we displayed the new mail. Simple as can be. The key thing here is, go ahead and hit enter real quick, thank you. The key thing that you guys need to remember is that when we call on a procedure, it's kind of like we take a detour in our program and we go do something else, but we come back. That's the key thing. So we start here. So let's just say each of these are our lines of code. So 1 and 2 was check mail. So I'm just going to stipulate that CM means check mail. 3 and 4 was check mail. All right, so now with that, let's go ahead. I'm just going to real quickly erase this out because that is, well, I'm going to be pulling it back off the shelf in just a second. So now when we do our program execution, we execute line 1, boom. We execute line 2. We need to remember where we're at. Well, we have we're just going to say a stack. We have a thing that we can put information on. So what we do is we push on the stack where we're currently at. Remember, this is a gross simplification, if you will. So then we come down here and we pull this copy out. We run the code. When we're done, we discard it because we're finished with it. So now we're finished. We got to return back. So now we're going to pop this off the stack. So we know where we were at. We just finished this line, so execution continues. So we're going to do this next. Then this. Now, so when we popped, so this was a pop right here, that means we basically took this off the stack. It got popped off the stack. So now the stack's empty again. Well, when we get down here to this particular line, what are we going to do? We are once again going to push where we're at. Again, ladies and gentlemen, a big simplification of the process. We push this onto the stack. Again, we pull this off the shelf. Once again, we start doing our coding. When we hit to the end of the coding, we're done, so this gets discarded. And what do? We pop this off the stack so we know where we're at. We come all the way back down. We continue with execution. There's nothing else to execute. We are at the end of our program. Logan, is this pretty clear?
All that means is whenever you hit a procedure where you need to go get something off the shelf and go into what looks like another block of code that's in a linear sense unrelated to your sequence before.
Right.
As you do that, you take where you're at, you push it onto the stack so that you can go back to it. The key is that way you can finish going through your check mail, whatever your procedure is.
Precisely.
Without worrying about where you're at until you're done. When you're done, you look at the stack. Mm-hmm. And that stack tells you where you were at in your code, and you can continue execution.
Exactly. That's the key thing here. Okay, so with that, let's go ahead and let's see. We've taken a look at a very simple procedure. Now I guess what we need to do is take a look at a very simple procedure that accepts parameters. All right, this is where things get a bit more sophisticated. If you guys remember, in episode 4, we talked about variables. And variables are places in memory in which we can store information. At the very end of episode 4, we spent just a second and we talked about scope. And it was a very light conversation because I said it would start becoming more and more clear as we got into procedures and functions and we had different areas in which we can establish these variables. Well, you guys are about to see where we can start tying variables inside of parameters, and those variables become protected. As a matter of fact, Logan, real quick, jump back over to Turbo Delphi. And go up right up underneath the procedure checkmail and do a var section. So Logan can create a variable right here. And inside var, go ahead and create a as an integer. All right, now we can come down into the begin and we can say that a equals 5. All right. Now, after we display our new mail, let's go ahead and output A. Let's write that out too, just so that we can show them that A is 5. All right, very nice. Now check this out. A's scope, the variable A, can only be seen inside this procedure. Logan, if I could, after we check our mail the final time, after this line right here, add a write line in there that writes A out.
As a matter of fact, we could just grab our existing line and try to write out A.
Okay, so A is not going to have a problem at all up here because it exists within this procedure. When we try to access A down here, it's not going to know what A is. A does not exist. So Logan, go ahead and compile this. There are errors. We can't. Oh, here we go. Check it out. Undeclared identifier, A. A doesn't exist. It just doesn't exist. Now, go ahead and comment that right line out. Now watch this. Now compile it. Ooh, it compiled just fine. Go ahead and execute it. Check this out. Just came into work. Now we're inside our procedure. So establish a connection, retrieve mail, close the connection, display the new email. 5. We used A. Now, we jump back out, so we go to lunch, and we jump back in, establish our connection, retrieve mail, close the connection, display new mail, 5. and then we jump back out again. Okay? So A exists, but only while we are in that procedure. So go ahead and hit enter on that.
It's just like the stack example, because as you were using those procedures, you were crossing them out when they were done.
That's what I was about to do. I was about to do this right here. Come over here. Now we have the variable A that exists inside our procedure. And so while we have pulled this off the shelf, so what I'm going to do is pull a new copy off. So let's pretend we just used it again. Our memory's getting used like crazy here. So here we go. We're using the code. We're using the code. A exists. We've put information in it, blah, blah, blah. We can use it, whatever we need to do. But the moment we hit the end of this procedure, we're done with it. It just goes back on the shelf. All variables that are created and used inside this procedure are now gone. So that's completely, scribble it out. That's gone. That is why when we return back to the program, to the part that called that procedure, it's outside our scope. We can't see it. That's why it didn't exist to us. Does that make sense?
Right. In an efficiency sense, the check mail procedure is pulled off the shelf, used, and then discarded simply because we don't have an infinite amount of memory within a computer.
Precisely.
We have packaged all of check mail into a single idea, and the goal of that is so that when it's done, it's discarded. That way, anything it had to do is taken back out of memory. So that way we're not sitting around with 1,000 different copies of A if we've checked our mail 1,000 times.
Exactly. Now check this out. Jump back over to Turbo Delphi. Let's look at this from a different angle. All right, so here's what I want you to do. I want you to take out the var A. Yeah, just go ahead and remove that altogether. Take out where the assignment and the right line. All right, beautiful. Now what I want you to do is go down into into our main program area, if you will, and do a var. You know what I'm talking about. So we're going to do a var right before begin. We're going to use it in the begin. So we're going to do A. Go ahead and do A, comma B. So we're going to create two integers. All right. So now in the begin area, let's go ahead and set A to 5 and B to 6, just like we did in episode 4. Now, I would like for check mail to print those out for me. So go up into check mail and do a right line with either one, A or B. It doesn't matter. All right. So now we're looking at it in a different direction. You see what I'm talking about?
Right. We have defined variables in the main part of our code, and we don't have variables defined in our check mail procedure.
Okay, so let's go ahead and compile this.
Or try to.
Yeah, exactly. So, there's errors. Go ahead and click OK. And once again, an undeclared identifier. So what's taken place here is, I'll jump back over here real quick into Photoshop. We've made these procedures. Hang on. So we've made a procedure down here, and we'll call it procedure X, and maybe we have another procedure, and it's called procedure Y. So we've got all of our different procedures. And then we've got our main code over here. The variables that we create over here, all these little boxes, right? They cannot be seen over here. It just does not work. Okay, does that make sense? It doesn't work. So I'll go ahead and pull that out. And any variables that are created inside here, they cannot be accessed over here. Again, does not work. So how do we get information from over here? So like this guy right here, how do I get him over here so that he can do something? And this is where we're going to get into parameters. Go back over into Turbo Delphi real quick, Logan. All right, check mail. We're done with check mail. Let's go ahead and create a new procedure. So go ahead and take that right line A out, and we'll leave the rest of it in place. Define a new procedure. So notice how I told Logan, define a new procedure. Here he goes, types out the word procedure. And the name of this is going to, let's call it add numbers. All right, and just give it a simple open closing parentheses. Terminate and begin end. All right, what I want you to do is we are going to basically write out the total of A plus B. So go ahead and give me a right line and send A plus B out to the console. So A plus B. Yeah. Now, of course, this is an error. We already know because it doesn't know what A plus B is. Yep, there's errors and there is the undeclared identifier. As a matter of fact, it hiccuped on A. Didn't even make it to B. Now, how do I get A and B into there? Well, we simply set up some parameters. So now watch this. Remember when we talked about the anatomy of a procedure? Inside these parentheses, this is where we can define parameters or information we can take in to our procedure. So Logan's going to go ahead and set it up so that we take in A, comma B, colon as integers. Alrighty. So now, if we compile it, all right, it's compiling just fine. It's just telling us the value assigned to B is never used and the value assigned to A is never used. So it's just kind of complaining a little, but it'll execute. Let's now go back down into the main code area, and where we've got just come back into work and all. Let's take all that out.
Okay.
So we'll clean it up now. We'll leave our old procedures in place. We've got 2 procedures defined now. Now I want to call add numbers, and I want to send this information 5 and 6, A and B, to it. So go ahead and call add numbers, and here's how it's done. Since we're sending information, Logan does an open parentheses. Notice the little tooltip that's giving us help. It's looking for us to send an integer to it. So let's go ahead and send it A. And notice how Logan put a comma to now designate the second parameter, and it's looking for B. So go ahead and put B, and then terminate. So now we are calling the procedure add numbers, and we are sending it A and B. Now check this out. This can be a little misleading. First of all, let's just run it and make sure it works. So look at that. 11 is what gets printed out. So we sent what was in A and what was in B into the add numbers procedure, and at that point we were then able to work with A and B. But is it the same A and B that's back originally defined in the code itself, not in the procedure, but in the begin-end program? Check this out. After you do add numbers, give me a write line down here, that writes what A is equal to. So he's going to write out A. And then give me one more write line and give me B. All right, so we run that and we execute it. Look at this, 11, 5, and 6. So we haven't done anything to manipulate, but now you may be thinking, well, that's because you didn't say A colon equals. Not a problem. Go ahead and close that. Let's go back into our add numbers procedure, and after we write that out, say A equals 10. So A colon equals 10, and B colon equals 1,000. All right, let's run it.
So, 5 and 6.
5 and 6. That's because the A and the B, you can go ahead and close that now, up in the procedures area, these 2 guys up here, they do not have any direct relationship whatsoever with the A and B that exists down here. That's their own variables. They were just populated with information when we called this guy.
Okay, we have a different A and a different B.
That's right, different A and a different B. As a matter of fact, Logan, I think you can prove that quite quickly. Change those names.
We could do something like
num1 and num2.
Our A and our B.
All right, now of course change the write line and all. All right, check it out. Go ahead and run it. It's still going to work just fine. Look at that, 11, 5, and 6. So the A and B that you guys saw a second ago, completely different. I mean, there was no association back and forth. We are just defining, here's the key thing, and this is where my beginners always get confused. We are defining a procedure that takes in 2 parameters. When we call the procedure, we have to send it 2 parameters. And that's what we're doing right here. We're sending it parameter 1 and parameter 2. As a matter of fact, these parameters right now are being sent in the form of variables. So whatever is in A is passed up here to our A, and whatever is in B is passed up here to our B. Did we have to use A and B down here, Logan?
No, we could use constants if we wanted to. We could put in our own...
hard code a number in.
So we could put in maybe 10 and 3.
10 and 3. So give it a shot. 13. Surprise. It works just fine.
Any mix of the above. We could do 10 and A.
Mm-hmm.
So then we get 15.
15. So it works beautifully. The key thing is you can set a procedure up to accept information in from the outside world. That's what we're doing here.
Or how about we jump back out to another real-world example?
Sure.
Let's say we had to throw away, where we throw a piece of trash in the garbage.
Okay.
Let's change that to a function that is vote.
Okay.
In vote, you take a piece of paper. In the old system, you take a piece of paper. You write some information. So you have information on it. Maybe A and B are candidates.
Okay.
And then you put that into a box.
So it's taking one parameter in.
So you've just executed vote, and vote took in a parameter. Now, it's still not like a function because there's no immediate return. You put that in, and for a while, for weeks even, nothing happens, or days, or whenever you voted. But so there's no immediate return. You vote, and that's it. But you have written information down, and you've sent that with your vote.
Mm-hmm. And then let's say we wanted the function, instead of being a procedure, to be a function. You put your slip in, and now it spits back to you a slip that says who the winner is. Make sense?
So instant voting.
So instant voting. I vote for me. Winner? You. Yay! Simple enough.
Or there's a hole in the bottom of the box, so you put your slip in, and then the guys before yours slips out.
There you go. But that's a procedure. It really is that straightforward. A procedure taking in parameters. We define the slots, as Logan just said, and we populate those slots with information. Now, for those of you that are programmers, we, of course, can pass by value and pass by reference. That's something we're going to be covering a little bit later on, because that's where we start getting into some serious power that we don't want our beginners to have yet, because if mistreated, bad things can happen. Don't you agree, Logan?
Yeah, it's because it confuses some of the ideas we've set up this far. If you don't understand all sides of the puzzle, then it's you just start stomping over all your values, and they become things you didn't want them to be.
For sure. So, at this point, I know this may be confusing to some of you out there. You just may have to play with it until you get comfortable. I understand the concept can be a little bit overwhelming at first. Taking in parameters, using those parameters. So these parameters, in essence, they're just variables. They're variables that are local to this procedure, but they are automatically populated when we call it, because we send information to populate it with. And it's a one-for-one. The first piece of information goes into the first parameter. The second piece of information goes into the second parameter.
And that's the key there. The naming doesn't define the order. You can have an A and a B on the sending and receiving ends, but at the end of the day, it's the order, not the naming. Because you saw originally we had A and B matching.
Right.
Now we don't. We have 10 and A on one side, and we have our A and our B on the other side.
Exactly.
The key is first parameter, second parameter, and so on to however many parameters you have.
Right. The bottom line is these are parameters, but they're variables. They have a type. In this particular case, they have of type integer, and we can give it whatever name we want, following variable naming conventions. Of course, we can't use funky symbols and stuff like that, and we can't use keywords as our variable name. So it's just like a variable, but they are parameters. So Logan, what if I wanted to send another piece of information that was of a different type? So let's say I sent 2 integers and I want to send a string.
All right, just like we were seeing in the variable lesson, even though the variable lesson was on multiple lines, and I'm going to leave this on a single line, the key is that we have to separate our types with a terminator.
Okay.
So, I mean, due to the rules of whitespace, we could put multiple lines here, but we're not going to.
That sounds good.
So let's extend this, and you want to add a string?
A string, yeah.
Okay. So, of course, we can't just put a string within this because we're defining all of these as integer. We need a new type. So we can terminate this, and then we can say that we can have s, and that can be of type string.
Simple enough. So now, if you compile it, you're going to get an error because when we call add numbers, we're only sending it 2 pieces of information, a 10 and an A. There's the thing, and that's the line I'm referring to in case no one was looking down there.
And there's the error.
Not enough actual parameters. Again, it's 1-for-1. The 10 needs to go in the first variable, our A. The A goes in the second variable, our B. Where's the third piece of information? So we need to put another comma. I like the question marks. And it's a string, so it goes inside single quotes, and we're going to send it cats. So now if we compile, it works just fine. And we can prove to you guys that cats did get sent to it because we can come up to our procedure and write out cats too. So write line, and we'll send out S. And you guys are going to see that S is populated with cats. Wow, that sounds scary. S is populated with cats. Wow. Okay, so let's go ahead and close that out. Yeah, I've been talking way too much today. All right, that's parameters and how we can set up as many parameters as you need. So let's see, the little things I wanted to write. I wanted to write the add numbers, and that really gets into everything I wanted to show for simple procedures without parameters and procedures with parameters. Now let's turn our attention to functions. Let's write a function. Now let's go ahead and let me get control real quick, Logan. Jump back over here into our whiteboard and get rid of all of that. Now remember, with a function, we call the function by its name. It's going to execute several lines of code. So remember, the function got pulled off the shelf. Execute, 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 execute. When it's done, it is going to send a result back to us. That's the key thing here. A result is sent back. So the first of these that I want to do is we're going to create a function called getInfo. And anytime we call upon getInfo, it's going to give us the date and the time that's formatted in a particular way, like, say, Monday, or what's today, Friday? Friday, November 3rd, 2006, 9:57 p.m. Okay? So we're going to simplify all this stuff, because that'd be a big date format line to get that looking right. So we're going to simplify it by just saying getInfo as an example. So let's go ahead and jump back over to Delphi real quick. And now our first look at how we go about creating a function. So the anatomy is just like a procedure for the most part. It starts with the word function because it is not a procedure. Now we, of course, need to give it its function's name, which is getInfo. And we'll do an open and closing parentheses. Now, here's the kicker. Before we would just terminate, put a terminator. That would be like a procedure. But now we're going to put a colon. And now we're going to tell it what kind of information is going to be sent back. What type of data? An integer, a string, or whatever. And in this particular case, let's send a string back. Because if I wanted to say November 3rd, well, November is a bunch of characters, and 3rd's a number that's being treated like a character, so it's just a string. All right, so now we terminate this, and we do the begin and end. All right, now we're ready to type the body of our code. And in this particular case, it's just going to be one line. And check this out. Remember how I said result? Well, that's the key word we're going to use here. So result. And then we just assign the result. So in this case,
we could start with a simple one just to show it in action.
Okay, so send back cats. No, send back dogs. There we go. So now, of course, if we compile, it should compile just fine. And it does. But we're not calling on the function. So again, it's sitting on the shelf ready to be called when the program runs. So let's go ahead and call on this function. So we can just, we can just add it right there for the moment. So we're going to getInfo. So check out how he's doing this.
Oh, right.
No, you're right.
If you want, we could show it this way. We could do something like getInfo. Because, I mean, if you're thinking we've defined it like and add numbers.
Yeah.
Because remember way back when we used to use check mail, all we would say was check mail. We didn't write anything. We said check mail. So why can't we just say
getInfo? Good point. Yeah, watch what happens here.
Right.
Compile.
Doesn't look like anything, but if you don't mind, maybe we could clear.
Yeah, go ahead. Absolutely.
These. So let's simplify this. The only thing we should be getting is getInfo, just in case it got confused in some of our other info.
Nothing.
We're getting absolutely nothing.
Nothing. We're not getting anything back. We need to do something.
Right, and the key here is all we've done is we've set our result. We haven't outputted anything, no output yet, but a result is set. So we need to use that result. So we're going to use that result by writing it. And we can do that by write line and then saying getInfo.
Ooh, that may look complicated. Well, we're inside our parentheses, so we have to do that first, which is getInfo. So it goes up and gets the getInfo function off the shelf and runs it. When it gets to the end of it, it has set the result, and we can now use the result with the writeLine function. Prove it.
And there's our output. Let me do one other example.
Do a string var. Yeah.
So let's make our string, and then set our string. I'm going to take these out for a bit. Say that our string is equal to getInfo. And then we can write out the contents of S.
Dogs.
And it works that way as well. So again, we are taking and getting a result back and putting that in. So we're running this. We could do other things. As a matter of fact, if you want, we could go and show that, do a write line.
Say, hi, we're in the function.
So do something.
Yeah, that sounds good.
And do a result. So we're running, as a matter of fact, I'll run it all and then I'll comment something.
Okay.
So we'll run, we get hi, indicating that, yes, okay, we're running things within getInfo, then we're setting a result. And later, we're writing that result.
Right. As a matter of fact, do this. Between those two lines, go ahead and put a right line that says, I'm back, or back from function. All right, so hi, back from function, dogs.
So we've put off using that information. We collected it, we stored it, but we put off using it until later.
Absolutely. So that is a simple function.
Or one other thing I want to show is that you don't absolutely have to use a result. I could take out where we were storing it. So let me just erase this. So we're just going to reduce this to getInfo and not write the results. As a matter of fact, how about we don't write anything?
Okay.
What happens if we run it by itself?
Okay.
We still get high red. So even though we never used the result, we just discarded it, it still ran.
Right. So it now just acted like a complete regular procedure. We didn't do anything with the result. So, again, just like a procedure. So, very cool. Anything else you want to throw in right here?
No, that's all I wanted to cover.
All right, let's make it meaty now. Let's go ahead and take the right line out of getInfo and then set the result to do what we was talking about a second ago.
And that was format.
Yeah, getting to some good stuff.
Time. And what does this do?
Now, and where does it come from?
Well, we could go and, let's see. Let me just try compiling it as is. And the first thing we're going to get is...
Yeah, we need to go ahead and...
Format date time. Okay, it's
declared in system utilities. Okay.
So we've got it.
So yeah, we were thinking it was in another unit.
Because in the past it was.
Yeah. That's cool. So let's go ahead and do it now.
Okay.
Just ignore our fumbling for a second, ladies and gentlemen. We're back. Yes.
So we're looking for a format and a date time. The format is going to be given in the form of string, and the date time is going to be a date time. Now there's a constant we can use called, or a function called now.
Right, and now will, as a matter of fact, you can show them now if you want to.
Running, you
like
mean
in help or yeah, there we go. So give it a second.
So it takes in a format and then the time.
And you want to just do a quick search for now and show them where now is in help,
or even
jump over like that.
And now is the now routine is a function that returns a tDate time. So that's the key there. tDate time is what we were looking for over here. tDate time, that's where we're getting it. We're using the now routine to get a date time that we can plug into format date time.
Right.
So now...
Actually, looking at this, Logan, let me see the mouse real quick.
Sure.
And you guys look very carefully. You should be able to start seeing how this all is pulling together right now. Constant format, string, and then date time. So we've got two different, look at this. How many terminators do we have inside the open and closing parentheses for this function? We have one terminator that's separating two pieces of information. We've got a string and we've got a tDate time. That's our two types of information that this guy is expecting to get. And he is then going to give us back, what? A string. So off of the stuff that you guys have just learned over the last 15, 20 minutes, or probably longer, you're starting to be able to see how some of this works now. I hope that this makes it easier for you to start reading the help and understanding what's going on.
Right, because procedures and functions make up the groundwork of the entire infrastructure that is the VCL.
Exactly. Okay, and don't worry about overload. We'll get into overloading functions and all.
But still,
later.
I mean, even ignoring the things that we haven't covered yet, like constant overload, still, 80% of that's not readable. We have function, the name, we have string, so we have types, and we have parameters.
Yeah,
so
absolutely.
A lot of that now makes sense.
Okay, so now let's put it to use.
All right. And let me bring that back up because I was about to look at the last part.
On the format stuff.
We got the date time. Now we need to supply the format. And what is the format? We can scroll down a bit and see how this works. Basically, the format is taken in as a string, which can be any combination of these specifiers. We can specify things like the day as a number without a leading zero, with a leading zero, depending on how many of each type of specifier you use. 1D, 2Ds, 3Ds, or we can start using things like M's for months and Y's for years.
And it's really straightforward. We can put other characters in there that are going to get printed out along with these key letters, if you will, that are designators for a specific piece of data.
We can even literally output letters like D. Even though D is used for day, it says here that if we enclose things in single or double quotes, they're displayed as is. So if we wanted to, we could even put the letter D into it.
Absolutely. So let's go ahead and put together the Friday, November 3rd. So what we need to do to pull this off is starting off with D, 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 D. Okay.
So that should be Friday.
And then we'll just have a comma drawn out there. So it'll be Friday, comma, then M, 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 M to get November spelled all the way out. And then space and DD. And then that's going to be November 03, then to give 1990 something. Wow, I'm in the past. To give 2006, we go Y, 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 Y. Okay, and then another comma. And then we're going to do H for the hour, colon. And MM for the minute, and then it doesn't matter, capital or lowercase, AM and / PM. So that's how we're formatting it. Again, let's just show them real quick because they might be thinking D, 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 D. Where do you get that from? So there it is, 4 Ds. Displays the name as a full name. Saturday or Sunday, Saturday, you get the idea. If we would have done 3 Ds, look at the line above it. Displays the day as an abbreviation, Sunday through Saturday. So you guys see, hopefully, how this works. Now we did Y, 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 Y. Let's scroll down to our Ys. Displays the year as a 4-digit number, 2006. So
then we've got things like the single hour. We've got things like the double minutes, which I've actually got wrong now. If you'll look back in the code, I wrote that as M. And M means month. N, double N means
whoops, we're just kidding,
minute.
guys. Yeah, so see, caught our own problem. All right, so and then there's the AM, PM.
And then I don't know if it shows the capital version, but yeah, AM, PM specifies that we're using the 12-hour clock instead of the 24-hour clock.
All right, so that's where we found all that information. And real quick, the way you jumped into like date format, tell them the hotkeys you're using over there in case they may have forgotten.
I was simply using F1. I was putting the cursor over the word I was curious in because you can't just be like out here in space or you'll open nothing.
Right.
Or you're over now and you'll open now.
And that finds topics related to. And
then the last thing that I did is, out of all these results, which were, I think 4 of them were format datetime routines, one of them was underneath the Delphi for Win32 reference, as opposed to things like Visual Basic or Microsoft Scripting or Indy.
Okay. Very good. Just wanted to point that out. So, again, putting the mouse over, hitting F1, and then selecting the one of interest. Okay, so now we're getting a result that hopefully we like. So let's go back down to our actual code between begin and end for the program. And let's write that out. So right line, the result of getInfo.
And I'm going to disregard this string just so it's not lying around.
Okay. So we run it. Friday, November 3rd, 2006 at 10:09 p.m. Ta-da. Simple enough. So that is the use of a function that is going to send back some information to us. So now what we need to do is take a look at a function that receives parameters and sends information back. As a matter of fact, watch this. You can change our procedure add numbers real quick to accommodate that. Watch this. Change this procedure to function, and at the end he gives it a colon, and he says it's going to send back an integer. All right. Let's go ahead and let's clean it up.
All right. So we don't want to immediately output anything.
Right.
We have an RA and RB. We can leave those alone. But we want to change this up. Instead of setting them, we're going to leave them whatever they were set. So let's clean everything.
So just a result colon equals our A plus our B. And that's it. And let's go and take the string out of the parameter section in there. Okay. And now let's take a look at how we can go about using it.
So we'll replace this down, or even do a new add numbers, and we want to add.
And we'll send it 5 or we pick some numbers. Doesn't matter.
5 and 10.
5 and 10. So now 5 and 10 get sent. You got one more parentheses to add. He's almost there. There we go. 5 and 10 get sent into add numbers. Add numbers then takes and adds our A and our B, which contain 5 and 10, and that's our output. That's what's in result, and that is then written out to our console line. So let's run it and check. And there we go. Friday, blah, 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 15. Excellent. So now we have a simple function that takes parameters in and outputs some stuff. So with that, here's another one. We have to get the application path often, right?
Okay.
So let's write a function that just says like get app path or something, so we don't have to type long stuff every time.
So, or we could just use the name that we've used 1 or 2 times in the past, and that was just app path.
App path.
We could make an app path function.
Okay.
So app path doesn't take anything in, but it returns a string. And its job is to take our, well, let's see, this is going to be a little bit tricky because the method I used to get it, a console app differs from a VCL app.
Good point.
VCL app has an application that can be accessed, and that contains the name. A console app retrieves all that information via command line parameters, and that's a different world.
Agreed. How about this? All right, let's put this off at the moment. We will use this as soon as we start doing our Mp3 player.
Yeah, that sounds good.
Because I know exactly what you're talking about. I don't want to get too confusing. So let's instead, how about we do something else that's real interesting? Guys, you'll may find that in these videos, very often we just kind of shoot from the hip and make stuff up as we go. Let's write the zero pad function.
Okay.
What if we needed to create a routine? So let's just talk about it at first. As a matter of fact, let me go ahead and jump over here to our whiteboard. And let's clear out all this stuff. What if we needed to create a special function that allowed us to send a number in, followed by however many numbers of padding we want? Let's say we're writing trying to think of an example of why we'd want to do this.
It's hard to say. It depends on the field of work you're in. If you're working in something like serial numbers, and you always have to fill up 5 digits.
Or 3D animation, and you're
and
dealing
that's,
with...
that's one of...
Yeah, that's an area that...
If you're rendering...
Yeah, if you're rendering, and let's say you're working with a compositor that's going to take in a bunch of files.
Or alphabetizing numbers. If you run into a problem like, let's just take something simple like 2 digits.
Okay.
You have 2 digits, so you count...
Oh, I see what you're getting at.
1 through 9, but then you get to 10, and now 10 begins with 1, so it goes above 2. So you have 1, 10, 2, 3, and it gets out of sync.
So if we pad these so that it looks like... let's say we're going to go from 0 to 99. So what Logan's saying is this beforehand would have been 0 to 9, and then we'd have been 10 up to 99. If we were to pump this through our function, and let's say we wanted our padding to be 2, so we sent it a number and we sent it 2, then we would have 0, 0 through 0, 9, 10 through 99. You'll notice how...
And that way 10 would come after 0, 9.
Right, that's been padded right there. So let's write a very simple function that will allow this type of functionality.
All right, and I'll jump back over to Delphi, and we'll start writing that. I guess I could just take...
Yeah, go ahead and just change that right there.
So 0 pad takes in what number you want to pad?
Yep, so what number, just like I drew it a second ago. Number and the length of padding, or we could call it length, or we can call it pad.
Yeah, I'll call it pad.
Yeah. And it's going to be, they're both of type integer. All right, so this right here is just set up the definition of what we're looking for. Now, in returning back, we're going to return a string back because if we're sticking with an integer, a 0, 1 is, 1.
Is just 1. We're sticking with this, just a numeric representation. In order to have padding make sense, we have to look at it as a string.
See, and we may... If we wanted to, we could then use this function with another routine we could write that would be like rename files, and then at that point you could use that to reassemble a file name that it's going to be renamed as an example. All right, so let's go ahead and jump into the function and let's get busy.
Now, to make this a little bit more clear, I'm going to define a local variable called s, and that is going to be a string, and I'm going to set that to be equal to the string version, because looking at this, some type of conversion is going to have to occur. We're taking in some numbers, this being the actual number that we want to work with, and we're returning a string. So that means at some point we have to convert over to a string. And just so that I don't have to do too many things in line, I'm going to do this ahead of time and keep it in a variable.
Right.
That'll just make things easier to read.
Yep, agreed. So we just simply do an int to string, and that converts the integer num over to a string and stores it into the variable s. Now, let's go ahead and set our result.
The result is equal to, Now, we need to introduce another built-in function, and this function is string of char.
Okay.
Its job is to take in one char, and then how many of those chars you want returned as a string. So if we were to feed it the letter A, the number 10, we would get 10 A's returned in a string.
Okay.
What we want to do here is return a number of zeros. The difference is we need to make our code a little bit smarter, because we can't just return given number of zeros, because if we had the number 1 and 4 zeros, we'd have 5 characters total.
Right.
If we had the number 10 and 4 zeros, we'd have 6 characters total, and our whole concept of padding would be off.
Exactly. All right, guys, so there's some very basic logic that's being used in this line.
So string of char, the char itself is a 0, so visual
we're padding
zero
these
padding.
with zeros.
And then the number of them that we want, it seems like it would be something like pad. It would look something like that.
Right.
But if we do this, that's way too simple. We're, disregarding the number, so we're just returning a bunch of zeros based on pad. So what we need to do...
hang on. All right, everybody hold that thought right there. So
let's get a visual idea of what's
happening. Let's get a visual idea. So first of all, what Logan is saying is that the function string of char works like this. It is first going to take in some sort of single character. So let's just use a Z. And then it's going to take in how many times do you want that to repeat. So let's say 3. So if we did this, and we put that inside a variable called
S. Or
yeah, let's just call it S. So S colon equals, which means up here we had a var. S is a string. Okay. And then, of course, we had our begin and end. So I'm just going to say bag and end. But you guys know what I'm saying. What's happening with this line right here, the way that this is written, is that if we were to show you what was in S after that line executes, S would contain, so here's S, and it would contain Z, Z, Z. Because we've said repeat the character Z 3 times and store that inside of S. So that's what's happening. So instead of a Z, what Logan has done is said let's repeat 0. And I'm going to jump back and forth for a second, so hang tight here. So we'll jump back over here. So he said repeat 0 pad times. So if we said let's pad it, remember that is the piece of information, the parameter that we're sending into this. So let's say we want it to pad everything with 2 zeros, right? Or so that the final output is 2 digits, if you will. So now what we need to do at the moment, what's going to happen is 0, and if we said 2, right now we're just simply going to have 0, 0.
As a matter of fact, I could just test this incrementally, because, I mean, there should be valid code. As a matter of fact, if I compile, it does compile.
It does, yep.
Let's just take a look at what we've got so far. I know this isn't all of the pieces of the puzzle.
Right. But we're close.
But we should have something. So let's see where we're at. So let's say 0 pad, and we wanted to take in maybe the number 4 and pad to 3 digits.
Okay.
So again...
so what's going to happen, my guess is, well, the number 4 is completely discarded, and we're going to have 3 zeros. And there's 3 zeros, and number 4 is discarded. So what we really want to happen is with a pad of 3, it needs to be 0, 0, and the number 4. Because it needs to have 3 characters in total when we're done.
Right. To begin with, we need to have num included at all. So we need to add... You might think add num, but we can't do that because that's a mismatch.
A mismatch, that's right.
That's a string, and this...
Remember, num is an integer, and the result... Let me go ahead and take this real quick. So the num right here is an integer, as defined right here, but the result right here is a string, because remember, this is where we're telling it what our return type in the function is going to be. It's going to be a string. So this is a problem. Well, Logan's already fixed that right here. Remember when we did a local variable declaration, we created S, and S is string, and then we populated S at the very beginning by using int to string. Convert the integer num over to a string and store that result in here. Logan can now simply do plus S. So now what will happen? When he runs this at the moment, don't run it yet, it's going to write out 0 pad, send a 4 into num. So we're going to have a 4 being stored in S. And 3 goes into pad. So now right here, what we get is a string of char. We get 0 3 times. So 0, 0, 0, 4. So we concatenate, since you see the plus right there, we concatenate a 4 to the end of 3 zeros. Let's try it out. What do you know? 0, 0, 0, 4. But we're trying to say our padding is 3, meaning in our case we would expect that our number sequence would never go above 999, right?
Right. Or if it does, then padding is no longer taken into consideration.
Exactly. So we need to somehow account for the fact that we don't need quite that many zeros. And it's real easy, actually. All we need to do is subtract the length of S.
I'm going to space that out a little bit too, just for clarity.
People are thinking, but the length of S, I'm confused. May I real quick, Logan?
Sure.
So if we were to jump back over here to the whiteboard, the length of S. So let's just come up here. And what was S? S came into it as a, what was we putting in there, a 4?
After conversion, S was 4. So the string that just contained one character, and that was 4.
Okay. And then we came down here and we said that the length, which was, we sent over what, a 3? So length, right, minus, and then what is the length of S? So what was the length of S?
Oh, it would just be 1.
1, because there's only one character. So length minus 1. So 3 minus 1 is?
2.
2.
And if we were to pad 2 zeros...
So now this whole thing, the result of this was actually a 2. So we get 0, 0, and remember we had plus S on the end. And that S was a 4. So we'd have that. So that is why up here when we have that it's the length of S. That's why we're subtracting that away from, and I called it length here. I meant to call it pad. That's why I was slowing down. There we go.
Because pad was driving the length, but yes, that's correct.
So let's go ahead and jump over here and go ahead and run it, and then I'll come back to what I was going to say. Go ahead and run it. And there we go, 0, 0, 4. So that is correct. Now go ahead and check this out. Give me another right line. This is the beauty of having functions now. And send it a, let's say, 9, no, hang on. Send it 25. All right, now execute it. So check it out. Only 1 0 got out of the So we got 0, 0, 4, 0, 2, 5. Our padding only required 1 0 to get us up to the proper length. And now let's see why. Go ahead and jump in here. So the first time when we came through, we said, let's take pad, which is 3, minus the length of S. Well, what was S? The first time around, it was just a 4. So pad 3 minus 1 says put 2 zeros in front. The second time when we ran this function, pad is still, of course, a 3 minus what's the length of S? Well, S this time around is a 25. So what's the length? 2. So what is 3 minus 2? A 1. That is why we saw only 1 0. So 0, 2, 5, and it was correct. So, looks pretty good to me. Do it one more time with 999. Can we run it? No zeros at all.
Because 3 minus 3 is 0.
3 minus 3 is 0. So our padding is, we're not going to repeat the zeros any. Excellent. Excellent example of a function. Now let's get even crazier. Let's make a simple extraction routine. What I want to do is I would like a function that I can hand a string of data to, and I want this function to extract everything between an opening and a closing parentheses and give me that information back. So come down here somewhere, or just so you can type for a second.
Down, out.
Right there is good. And type some data, and then have a parenthesis in there and some data inside of it. So this.
Let's see. So let me think for a second.
Oh, like an any file.
And let's say last num is equal to 57.
So actually, we're going to change this on the fly. We're not even going to use parentheses. We're going to be able to tell the function what I want it to use to extract information within. And so forget it. We're not even going to use, see guys, we're building this on the fly. And this is really cool because let's say we pulled this information out of a file that was written and we need to extract this right here. So couldn't we write a function that says take all of this information in and use our start marker and our end marker, and we can define those. And I want the function to give us whatever is inside back. Okay, so it's going to be returning data back. So go ahead and just comment that out at the moment. All right, let's make it. Yeah. I was going to do parentheses at first, but screw that. Let's make it dynamic. So function. So the first thing we need to do, let's call this get between. All right, first thing we're going to need to do is set up the parameter s. This is the data that we're sending it in. So this is where we would have sent all of last num. All right, our next variable is going to be, let's do them as chars, just single characters.
Right, just keep things a little bit simpler.
Right, so let's do start marker and end marker.
And those are chars.
All right, and now this is a function, so give me a colon. And we're going to return a string. Ah, beautiful. All right, give me a begin and end. And go ahead and stretch this just a little bit so they can see the whole thing over there. Yeah, that's what I'm talking about. All right, we need to go ahead and create some variables at the beginning here that we're going to need. So it's two integers. We need a start position and an end position. So two places in memory that we are setting up to hold a starting position and an ending position. All right, now we're ready to code. We need to find the start position of the data that we're going to send back, right?
Right, because if we look back down here, our data, we're considering this the data, and this is our entire string. So that is going to be S.
Okay.
And this is the data, which we don't know about yet, but we do know that this is the part we want. It doesn't start at the beginning. It starts at some distance into the string.
Right. Oh, check this out. Let's do this. Before we start putting the meat of the function in, let's go ahead and come down here and call the function. We won't compile it yet, but just so everybody will see how our parameters are set up.
So we're done with our zero padding.
Yep, we're done with the padding. So we'll do get between. Oh, yeah, that's fine. Yeah, right line. So we'll write the result out. All right, so now we're going to do get between. And then the first thing that we're going to need to send it is going to be a string. So do you want to...
You can just type it in.
Just do an open, a single quote. And do last num equals quote 57. Double quotes, yeah. All right, and then single quote. And then we're going to do a comma. Now it's expecting a char, so a single quote. And give it a double quote and a single quote. And then a comma. And then we need to give it an end char. So same thing. And then closing parentheses, terminator. Yeah! So there we go. That's how we're sending information in. And if I can, real quick, Logan, just so that they see. So up here, S is going to hold this whole thing. And then we got start marker, which is going to hold double quotes. And then we have end marker that's going to hold double quotes. What's cool about this setup is it's designed in such a way that the start and end symbols can be different if we wanted to.
That's right, because, parentheses are used very often to hold data.
Yeah. So now let's go ahead and start coding it in, and we'll explain logic as we go.
First thing we need to get is the start position. And to do that, we're going to use the position function, which takes in a part of a string out of a whole string, or a substring and a string. So the substring is the marker. So this is going to be our start marker, because this is the start position. And we're looking this out of the entire string that we've been sent.
So to really simplify things, what this does is it says we're going to find and report back the position of where this particular string is found inside this string right here. So start this guy right here. He is a char. What is he? He is a double quotes. That's what we're sitting in. So we're looking for where do double quotes appear in string and give us the position of it. So we're going to store that over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If you were to stop right here and write that out, let's see what we got.
So if we were to just right line start position and run it.
9.
There we go.
Just like I showed. Okay, but that tells us where that parenthesis is, right? But the information we want to keep is going to start the character right past it because, again, let me come over here.
The ninth character is that.
So the ninth character is this.
Oh, I've got an idea.
Oh, yeah, go ahead.
So let's say we've got our start position right now. It has a 9 in it. So far we're thinking that ninth element is that quote. Let's see if it is. We can take S and we can grab an element out of that.
Ooh, based off of what we taught them in episode 4. Right. I like it.
So let's grab that one char. What is the ninth char?
Ooh.
It is a quote.
So what if we were to take our start position and increment it one more?
So going back to here when we were setting it, we were getting the position. What if we added 1?
So we said go to the next character because that is what's going to be of relevance to us. That's where we want to start with this data. And that should be a 5.
And it is a 5.
Beautiful.
So we know that we now have our start position set correctly to start getting data out of our line.
So how about now we use a delete command, or delete function, and we kill everything up to our starting data.
Okay. We could use the delete procedure, which takes in what string we want to work on, where we want to start.
At the very first character, delete from there all the way up to
start position.
But since start position has 1 added to it, we don't want to kill the 5 from the 57, do we?
No, so we need to jump back 1.
So we need to just tell it to jump back 1.
Like so.
You guys follow that? Do you understand? All right. So let's go ahead and let's write out S afterwards. So we'll just take the start position out. So we're writing everything that's in S at this moment. Let's do it. Ah, sweet. So we're S at the beginning. As a matter of fact, go ahead and hit enter real quick. And go ahead and right line out S. Just copy that whole right line S out and put it right before we start it all as well.
So you mean right before we delete?
No, paste it there and paste it right before start POS up above. Yeah.
So what we started with and what we ended with.
Yep. So we run this. In the function, we start with last num equals quote 57 quote. But then after we get done with populating the start POS integer and then doing the delete function, we end up with 57 quotes. So we're almost there. We just need to get rid of that other quote now. And this allows us to introduce you guys to yet another thing. But we need to find out where our in position is, don't we?
So we've got a way to remember it. Now we need to populate that variable. So we could say end position is equal to...
And we're going to do a POS again. And now we're going to take our in marker and S. So we're looking for our in marker, which is going to be quotes, and in the string S, which is just a 57 quote. That's all that's left. And then again, we want to do a -1 because in this case we don't want to. What's the word I'm looking for? Keep the quotes. We want to back up 1.
Let's look at what that would be if we were to, let's say, right line S and look at the end position character.
Okay.
What does that hold? Well,
it holds quotes. It holds those last quotes. We need to back up 1 so that it's now holding a pointer to the 7. We need to point to 7.
Right. So
before we had to step forward by adding 1. Now we have to subtract. Let's make sure it's holding a 7. We're now looking at the last piece of information. So check this out. Don't mess up. Just go down here to where it says last num 57. Put 66 right before that 7. Now run it again. Still no 7's the last thing. Look at that. The middle line right there, it still took that first quote out and everything before it started at the 5, 6, 6, 7. So very, very nice. All right. So now we're ready to do the final piece.
So that means since we've gotten this far, we have everything established. We just need to use it.
We need to use it. And this is where we're going to introduce you guys to yet another function, and it is copy. So we're going to go ahead and populate the result because we really are at the end and we're ready to send information back. So we're going to give it the string, and we're going to copy from position 1.
So that would be from
the start. Remember,
from the very beginning.
Exactly. Where a second ago you guys saw that the beginning was 5. As a matter of fact, the last example said 5, 6, 6, 7 double quotes. And we're going to copy starting at 1 for how far? Well, in position. And remember, in position ended at 7. So right before those double quotes.
So
that's our result.
That looks right.
So now let's go ahead and take these other right lines out. So now we can clean it up because we are truly at the end of this. So now let's go ahead and run it. 5, 6, 6, 7.
Very nice. Now, in putting this together, I noticed some things that I didn't before we looked at it under closer scrutiny. I believe we can remove the add 1 here and subtract 1 because we're just subtracting off that same 1. So it's redundant. We can clean this up a bit
but come
further.
on, it was kind of cool that it allowed us to...
It did show a few things with offsets.
Logically, what's happening with offsets and offsets.
That is indeed working.
And check this out. The data really does change. Take the 5, 6, 6, 7, add a bunch of other junk in there.
So we could put other things, because it's not just like it's limited to numbers. We could put cats, like 5, 6, 6, 7,
all right,
and 2. So
okay.
A bunch of data.
Very nice. Very
so
nice.
The only thing that starts and stops it is quotes. Now let's change this around a little bit. So we have 2 different types of characters. We can have a parenthesis for an opening and the closing parenthesis for a closing character. And to begin with, this isn't going to return anything because nothing is between parentheses.
Beautiful.
So let's change this. Let's put our data between parentheses.
Ah, nice. Now we know that this isn't perfect. There's ways that we can have some errors inside here.
There's ways we could have errors. There's probably 100 different ways you could do this, because you could see we did our copy at the end. We could have set S to equal the copy and then just return S.
Right.
So it would have looked cleaner. But I mean, again, there's 100 different ways you could do it. We could have even ran a final delete. We could have taken in our end position, ran a delete, and then returned S. So like I said, there's probably 100 other ways.
Yeah, exactly. The goal, though, is to show you guys the creation of yet another custom function that does some sort of work on data and returns a result, returns data back to us. And that's what we've accomplished here. So, real quick, let's jump over here to Photoshop. And, wow, that's kind of scary. Clear all that out real quick. So, what have we looked at, or what have we learned in this video? Well, we learned that a subroutine is, in our particular case, a function or a procedure. And they are nothing more than a block of code that has been packaged that is going to sit in memory waiting to be called on. Your program needs to call that code, and when it calls it, it gets pulled off the shelf, and it gets executed. It gets to the very end. When it gets to the end, it's then discarded, and we continue our execution in our main program. Procedures don't give us anything back. Let's do that. That looks better. But functions will send information back. Very key thing. Now, there's a couple of things that we have not touched on, and we will get into this a little bit later on as we dig deeper, because this video has already been going on for quite a while. But that is, we do have the ability to do nested calls. And we also have the ability, this is a great one. Recursion. A nested call is, let's say we've got 2 different functions sitting over here on the shelf, and inside this function, like right here, is a call to this function. So then when this function is over here, let me just kind of clean this up for just a second. When this function right here gets called, and we start running it, we get to the spot where we then call this guy. So this guy gets pulled off the shelf. We remember where we're at. This gets, remember, pushed onto the stack as to where to return to, which means the return place up here, let's say this was number 1, which got pushed onto the stack. We'll call this number 2 right here. So number 2 got pushed onto the stack. So then when we come down here, we pulled this one off the shelf. We ran this code. When we got to the end, remember, what do? We pop off this, where do we need to return to? So we pop that off, meaning we come back to right here. We finish the execution. When we're done with this one's then put back on the shelf, and we pop the next number off, which then returns us back to right here, and we keep going. That is nested calls.
Right. The items on the stack can refer to different places and different procedures and functions.
Exactly.
So as you go through and execute different things, you always return to where you were, regardless of if that was your main program, a procedure, a function, or a different procedure.
Right. So we're not going to return, when this gets done, we're not going to return from here all the way back up to here. We have to return to the caller.
No, because number 2 on the stack was within that procedure.
That's right. So that is nested calls. We won't be getting to that until a little bit later on. Recursion is where you have a procedure that internally has, so line of code, a call to itself. Got to be real careful here, because if you're a complete beginner and you get into writing procedures that call themselves or functions that call themselves, then you can real quickly end up with stack overflows and really nasty stuff if you let it run away and get out of control. We'll start hitting on recursion a little bit later after you guys are good and comfortable working with procedures. So, have we covered everything we needed to? Let me grab my notes here. We started out, we asked, what are they? Well, we told you guys they're chunks of code that's basically packaged up, designed to perform a specific task at hand. Why do we need them? Well, we talked about all the reasons why we needed them. We need to reduce redundancy in our programs, modularize our code, and we can easily reuse those modules in other programs. Reuse those procedures and functions, that is. We keep complex programs simple, and we improve program readability. The two types of subroutines that we have here are procedures and functions. And then we talked about the anatomy of one, the shell, if you will, where we actually declare it. And then we talked about how it can take parameters in. We talked about the body of code that is within this shell. And finally, if it's a function, the ability to return information back. Logan, at this point in our future VTMs, I think we're now set up so that we can use procedures and functions. Ladies and gentlemen, we'd like to thank you very much for joining us with this video. I know this may seem a bit overwhelming. If you are new to the concept of creating procedures and functions, you may need to watch it a couple of times. Maybe even try creating some of your own procedures and functions until you get the hang of what's going on. Well, with that, Logan, I think we're ready to start with the basic MP3 player. So, guys, we're signing off on this video. Thanks a lot for joining us.